Hello friends, in this video I am going to explain the introduction about the tree data structure. At the end of this you are able to learn what is a tree, root node, and what is a leaf node, what is an edge, what is a path, parent and child nodes, and what are the siblings, and you can understand what is the degree of a node, what is the level, height and depth of a tree. These are the basic terminology which we used in a tree data structure. What is a tree? A tree is a non-linear data structure which organizes data in a hierarchical structure. What is meaning of hierarchical structure? The data is stored in the form of levels. Or another definition we have, a tree is a connected graph without any circuits. Here I have an example. This is a graph. Why I am calling this as a graph? In this, there is a circuit. So if any connected graph without circuits, then only it is called as a tree. Any graph which contains circuit, that is not considered as a tree here. This is an example for tree. In this, the data is arranged in the form of hierarchical structure and there is no circuit here. So that's why we can take this example as a tree here. And what is a root node? In every tree, the individual element is called as a node. You can take this as an example tree because here also there is no circuit, and we can consider this as A as a node, B as a node, C as a node and G as a node, like this. Every individual element is considered as a node. Among these nodes, the first node which originates, so which is the starting node, that is considered as a root node. And in any tree there must be only one root node, so we don't have multiple root nodes in a tree data structure. For any example tree, that contains only one root node. What is a leaf node? The node which does not have any child is called as a leaf node. So in this example, the lowest level of nodes D, I, J, F, K and H are considered as leaf nodes. So why? Because these nodes are not having any child nodes. And we can also call these leaf nodes as external nodes or terminal nodes. And the other nodes other than the leaf nodes, so these are called as internal nodes or non-terminal nodes. And what is an edge in a tree? The connecting link between any two nodes is called as an edge. As I told you, every individual element is called as a node here. A is a node and B is a node. The connecting link between these two nodes is called as an edge. There is a question that if I have n number of nodes, how many edges will be present? So here in this tree, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Totally we have 11 number of nodes. So this is the n value. If we have 11 nodes, there must be exactly n minus 1, that is 10 number of edges. So those edges are this one 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these are the 10 number of edges for this tree. And what is a path? In a tree data structure, the sequence of nodes and edges from one node to another node is called as a path. So we have to take one node from that node to any specific node. So we can explain this as a path. So I want to tell from A to J. So the path from A to J is A to B, then B to E and B to J. So this we can represent here. So A to B to E and then J. So this is actually called path. In any tree, the path is a sequence of nodes and edges between any two nodes. For example, if I say C and K, the path is C, G and K. This is a example of path. What is a parent node? The node which has a branch from it to any other node is called as a parent node. So if any node, let's take A, from these nodes we have other nodes. So those are branches. So from this node we have B and C. So in this case we can call A as a parent node and B and C are called as a child nodes. So again in this case B is having three childs. Those are D, E and F. So we can call this B as a parent node. In this case D, E, F are called as a child nodes. And in a tree, a parent node can have any number of childs. So in this tree, this A is having two childs and B is having three childs. So like this, a node can have any number of child nodes. As we have seen in the previous example, a child node is nothing but the node which is descendant of some node is called as a child node. In this example, D is a child of B and C is a child of A. And what are the siblings? Node which belongs to the same parent are considered as siblings. So here if I take D, E, F, these D, E, F nodes are belongs to the same parent. So we can call D, E, F are siblings. And I and J are belongs to the same parent E, we can call I and J as a sibling. And G and H are siblings of C. The point here is the nodes which are belongs to the same parent, those are called as siblings. What is a degree of a node and what is a degree of a tree? First we will see what is a degree of a node. It is the total number of children of that node. For example, I want to take A here. So the degree of A is how many number of children A is having. So A is having B and C. So the degree of A is 2 here. A is having 2 number of children. And B is having 3 children. Those are D, E and F. So degree of B is 3 here. Degree of C is, it is having 2 children. So degree of C is 2. Degree of D here, D is not having any child nodes. That's why degree of D is 0. And E is having 2 child nodes. Degree of E is 2 here. And F is not having any child nodes. Degree of F is 0. Degree of G is, it is having one child, so degree of G is 1 here. H degree is 0 because it is not having any child nodes. And I is not having any child nodes, so degree is 0. J is also having no nodes, 0. And K is not having any nodes, that's why degree is 0. And what is the degree of a tree? So among all these nodes, so what is the highest degree? So here B is having highest degree 3. The degree of this tree is 3 here. Degree of a tree is the highest degree of a node among all the nodes in a tree. First compute the degree of all nodes. Among all those nodes, find out what is the maximum degree. So that will become the degree of a tree here. And what is a level? In a tree, each step from top to bottom is called as a level of tree. The level count starts with 0 and increments by 1 at each level or step. So here A is at level 0, B and C are at level 1, D, E, F, G and H are at level 2, I, J, K are at level 3. So we'll see two general terms. What is a height and depth? Whenever you want to find out the height of a person, so you will find out it from bottom to top. Then you can tell the height of a person. And I want to find out the depth of a well. I can start from top and I will go to the bottom. Whenever I want to find height, I will follow bottom to up strategy. Whenever I want to find depth, I will follow top to bottom strategy. Now you will see two terms here. What is a height of a node and what is height of a tree? So let's take the first one. The total number of edges that lies on the longest path from any leaf node to a particular node is called a height of a node. I want to find out height of B here. So from the leaf node, as I told you, height is calculated from bottom to up. From the lowest level of node, let's take I here, to B. Find out total number of edges in between. So this is one edge and this is one edge. So height of B is 2 here. And for example, if I want to find out the height of A, so then start out from the leaf node, the number of edges, this is first edge and this is edge 2 and this is edge 3. The height of node A is 3 here. And you can calculate the height of H from the leaf node. We have to calculate this itself a leaf node, so that's why height of H is 0. So we can have height of all leaf nodes will be always 0. Now we can see height of a tree. So height of a tree is the height of a root node. Height of a root node A is 3 here, that's why height of a tree is 3. And now we'll see what is a depth of a tree. We have seen depth is calculated by using top to bottom strategy. The total number of edges from the root node to a particular node is called as depth of a node. For example, I want to find out depth of B. From the root node, we have only one edge to B. So the depth of B is 1 here. Now, I want to find out the depth of H. From the root node, we have 1 and 2 edges. So depth of H is 2 here. Here we have another definition, that is depth of a tree. The depth of a tree is the total number of edges from the root node to a leaf node in the longest path. So in the longest path, so these are the leaf nodes. We have I, J and K. For each of these leaf node, the depth is 3 here. So for example, let's take the depth of I here. From the root node, this is the first edge and this is the second edge and this is the third edge. Similarly to the J, also it is having 3 number of edges, and for K also the number of edges between root node to the leaf node are 3 here. So finally we can consider the depth of a tree is 3 in this case. These are some basic terminology that we use in tree data structure. If you have any queries, please comment in the comment section. Thank you for watching.